everybody. So this lesson I thought had some pretty hard problems, and I wanted to show you the quick check is pretty much all word problems, and the math that you do to do these problems has a lot of steps. Okay, so what I wanted to do in this video is I wanted to give you kind of these steps here for, in general, how do you subtract? Okay, when you're in scientific notation. There is a vocab term I wanted to go over here, and that's coefficient. And then I have two problems that I'm going to do for you. One of them's from the practice, and the other one's from the quick check. Okay, so a little bit of free math for you if you stick it out. All right, guys. So first of all, let's talk about this word coefficient. Okay, coefficient. It says a number used to multiply a variable in an algebraic expression. Okay, except in this lesson we don't have any variables. Okay, we do have some expressions. So when you're in scientific notation, okay, you're gonna have a number that is greater than 0, but less than 10, greater than or equal to 1, but less than 10. And then it's going to be times a power of 10, right? So it has to be greater than or equal to 1, but less than and not equal to 10. Okay, so we always just say there's one digit in front of the decimal place, okay? And then it's going to be times 10 to some power, okay? And that's what scientific notation looks like, okay? That's how it's defined. Let me show you where the coefficient is. It's this part, okay? Is it times a variable? No, it's times 10 to some power. Okay, so like on this anchor chart that I have here, the 41.3 is the coefficient in this expression, the 0.625 is the coefficient. Okay, but so if you see that, what you want to think is just that's that first part, that's just a number that has one digit and then the decimal place. All right, so that's the coefficient. Now, here are in general, the steps that you're going to follow when you do this process, okay? First, you're going to make sure both the numbers are in scientific notation and have the same exponent, okay? And if you didn't watch the video in the previous lesson, that was because when we have the same exponent, we're subtracting the same thing, like 5,000 minus 2,000. Well, we all know that's 3,000, right? And so here you have 5 times 10 to the third power minus 2 times 10 to the third power, okay? If your power of 10 matches, you're subtracting the same thing, thousands, 10,000s, millions, billions, okay? You're aligning the place value when you do that, okay? And then you can just subtract the numbers. And now you get 3,000, also known as 3 times 10 to the third power. Okay, so that part of it is the same as when we added numbers in scientific notation. And again, that first step, you've got to get a match in the exponent. All right. Okay, subtract the coefficients. So that's what I did here, the 5 minus 2 equaling the 3. Okay, then once you're done there, if you're not in scientific notation, you've got to get it into scientific notation. Okay, in steps 1 and in step 3, you might use this left add, right subtract thing. Okay, and I'll show you that. That's just a way to make sure that you're keeping the number the same even though you're changing that exponent. Okay. So this problem says Earth's radius is approximately 3,959 miles, while Jupiter's radius is approximately 4.3441 times 10 to the fourth power miles. How much bigger is Jupiter's radius compared to Earth? Express your answer in scientific notation. Do not round your answer. Okay, so when I see this question, how much bigger, okay, how much more? To me, that means plus what? Okay, so you have Earth plus, we don't know how much, to equal Jupiter. Okay, Jupiter's like this huge planet. Earth's like a pretty small planet. So how much bigger is the Earth's radius? That's what we're trying to figure out. Okay, and this is kind of going to be my equation. I'm going to put Earth plus something, question mark, equals Jupiter, but then I'm going to fill in the amounts that they've given me here. All right, so I haven't even started my 3 steps yet. Let's do step 1. All right, so they don't give Earth's radius in scientific notation. I'm going to have to put it in scientific notation. So 3,959 times 10 to some power I don't know yet. I'm going to figure it out. Decimal point is here. I need it to be here. That means I have to move it 1, 2, 3 times to the left. Okay? Left add, that's a positive power of 3. Also because it's a big number, right? Okay? The numbers less than 1 are the negative exponents. All right, so now I have the numbers in scientific notation, and I'm going to have 3.959. I told me not to round, so I'm going to keep all of those decimal numbers, times 10 to the 3rd power, plus something, that's the thing I'm trying to figure out, is going to equal this number right here, Jupiter's mass, 4.3441 times 10 to the 4th power. Okay. I do not have a match in my exponents. Okay. So I did the first step right in scientific notation, but my exponents do not match. So I'm going to look at Lars, and I'm going to go ahead and I'm going to turn Earth into an exponent of 4. So I want the exponent to be 4. That means I'm adding 1 to 3. So now I have 10 to the 4th power. Okay. But if I added 1, that means I'm going to have to move the decimal to the left. Okay. That's the L in Lars. Move it to the left. Okay, because I just went from thousands to 10,000s. Okay, I'm not going to have 3 of them anymore. Okay, I had 3,000s. I'm not going to have 3 10,000s. All right, so I've got to make the coefficient smaller by a power of 10. What I really did here was divide by 10. Okay, so now what I have is 0.3959 times 10 to the 4th power plus something is going to equal 4.3441 times 10 to the 4th power. Let me move my little mini cam here. There we go. All right, so if I don't know how much is added, I'm going to subtract to figure it out. Let me get a different color. I'm going to subtract this on both sides of the equal sign. And now I'm going to do step 2. I'm done now. I can do step 2, subtract the coefficients. Okay, you can do this with a calculator. I'm just going to do it old school just because it'll just give you a chance to think about what's going on. 13 minus 5 is 8. 3 minus 9, can't do that, borrow. 13 minus 9 is 4. Borrow from here. 12 minus 3 is 9. Bring down the decimal point. All right. Okay. So now I have 3.9481. It is still 10 thousandths. 10 to the 4th power. Okay. So now step 2 is done. Step 3 says adjust the decimal if needed. Okay. So remember that in scientific notation, this coefficient needs to be a 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and decimals in between are fine. And it is. Okay, I've only got one digit to the left of the decimal, so I'm good to go there. I don't have to do another large adjustment. That one is done. Okay, let me just show you how you would have to enter it here. You're going to enter the 3.9482 in that first box. Let me move that because that got a little bit messy. Oh, I'm going to have to erase it. Oh well. That'll go in the first box there. And you've got to enter all of it because they said not to round. Okay, so in this first box, you're going to have 3.9482. In this second box, you're going to have the power of 10. Okay, and when you type it in, you're going to use the button that looks like this, X with the box above it. That's the button that you need to click, and then you can enter the 10 to the power of 4, and the 4 will be a little exponent. All right, so again here, all of the steps that we did, let me label them in a nice purple color. Write in scientific notation. That's what I did here. Earth was not written in scientific notation, so I had to do that. Okay. Then matching the exponents, that's what I did right here. This was still step 1. I had to move the decimal to the left in Earth because the exponent was 3 and it needed to be 4. Okay, how did I know to move it to the left? That's where Lars came in. Okay, I needed to add 1 to 3 to get it to be a 4. And so if I'm adding 1 to the exponent, I'm going to make the coefficient smaller by 1 power of 10. I'm going to move to the left. Okay, I've got to keep that balance so that it still equals the same number. Step 2 was to subtract the coefficients. I did that all the way over here. Okay, and in this problem, because there was only one digit to the left of the decimal, I did not need to do step 3. It was already in scientific notation. All right, let's do another one. That has so many steps. My goodness. Okay, so here's this one. Platelets and red blood cells are components of blood. A typical platelet and red blood cell have diameters of approximately 2.33 times 10 to the negative 6th power meters and 0.00000075 meters, respectively. Okay, when they say respectively here, you guys, what they mean is that the first number goes with the first thing they said. Okay, they said platelet first, so this number is the platelet. Okay, they said red blood cell second, so the second number here is the red blood cell, and that's important. Okay, that's what they mean by respectively. Which blood component has a bigger diameter And approximately by how much? All right, so let's remember our steps. The first step is write both the numbers in scientific notation and get them to have the same exponent. 1, 2, 3, 4, 5. 3, 4, 5, like that. Okay, so first I'm going to write it in scientific notation. 1, 2, 3, 4, 5, 6. I have to move the decimal 6 times to get it to be where it's supposed to be. Remember, we're supposed to have one number to the left of the decimal, and it can't be a 0, okay? It has to be greater than or equal to 1, but less than 10. Okay, because I moved to the right, I'm talking about an itty-bitty number here. When we move to the right, we need a negative exponent. So this is what I have here. And hey, look you guys, I have a match. Oh, I'm so excited. I love when the exponents already match. It gives me one less thing I have to do. All right. Okay. So now what we're saying, which component has a bigger diameter? And here's that again. By how much? So we're asking how much bigger. Okay, how much bigger means plus what? And if you don't know how much you're adding, you're going to subtract to figure it out. Okay, so I am going to take the 7.5 times 10 to the negative 6th power, okay? And we don't need to know what that is. We know it's an itty bitty number. I don't know what it's called, okay? But we've got a match, and that's all we're worried about. We're going to subtract the 2.33 times 10 to the negative 6th power. All right. And so step 2 is subtract the coefficients. So remember, this is what we are subtracting. Okay, we're not going to subtract the power of 10. That's telling us, you know, how big the magnitude is. We're not going to subtract it. Okay, so let's go ahead and subtract this. I'm going to add a 0 here. Going to borrow. You can totally do this part in the calculator, no big deal. 4 minus 1 is 1. 7 minus 2 is 5. Okay, the power of 10 stays the same. And now for step 3, I'm going to think about, is my number in scientific notation? And because there is only one digit to the left of the decimal and it's not 0, I'm going to say yes, this is already in scientific notation. Woohoo! All right, so that one's done. Okay, and then we just need to pick the right choice here. I've got 2 with that answer, so let's read the other part. So is the red blood cell bigger or is the platelet bigger? Let's go back to the problem and reread. Okay, I told you that respectively thing was going to be important, and it is. Okay, so which one is the red blood cell? Remember, the red blood cell was the second thing they named, so it goes with the second number they wrote. That means this guy is the red blood cell. And it is bigger. Since they have a match in their exponent, you can just look at the coefficient. Okay, 7.5 is bigger than 2.33. So the red blood cell has the bigger diameter. This is the one we want right here. All right, guys, good luck with this. If you struggle with it, be understanding. Okay, take a break and then come back to it. You'll get it. All right.